Good day everyone. In this video we will learn how to use library RnaSeqSampleSize to calculate the power and sample size of relevant studies. We will focus on two important functions. The first function is sample size and the second function is EST power curve. And let's have a look at the help file for RnaSeqSampleSize sample size function. This function will ask for the following argument: the power, the total number of genes for testing, and the expected number of prognostic genes, FDR level, which is a false discovery rate level, and K, which is the ratio of sample size between the two groups, also W, ratio of normalization factors between the two groups, Rho, which is the minimum fold changes for prognostic genes between two groups, and lambda 0, average read count of prognostic genes, and phi 0, which is dispersion for prognostic genes. The other function is EST power curve, which is a pre-step before plotting the power curve, comparing different arguments, as we will see later in this video. The only disadvantage in this function is that it does not have the argument K, which is the ratio between case and control. So until the moment of production of this video, this function only gives you a one-to-one plot. This function will calculate the power, providing the number of samples and ratio of normalization factor between two groups, minimum fold changes for prognostic genes, and average read count, dispersion of prognostic genes, and alpha level and FDR level. We will start with this function, estimate power curve. To calculate the sample size, you either get a range of lambdas and phi from literature, or from pilot study, or from an expert opinion. So let's assume for simplicity we have two lambdas, 5 and 10, and two phis, 0.25 and 0.5, and we use the function expand grid to give you all possible combinations between 5 and 10 from one side and 0.25 and 0.5 from the other side. So we'll create all possible combinations and store it in a data frame called my data frame. So here are the possible combinations. Let's rename these two variables. So now lambda zeros and phi in the first combination is 5, 0.25, and etc. till the end of the table. We will use the proposed number of samples in each group, and we put here to start with 50, and we create a loop and store the result of each loop in the list my SS or my sample size. And in each loop, the estimate power curve function will use the n. The expert opinion is W is 1, FDR level 0.05, rho is 2, and lambda and phi will take the ith element of the data frame. And let's run the loop. Okay, before I proceed, I just want to emphasize that EST power curve does not have the argument K. So now you have the object my SS, which is a list of 4. You can have an overview. Each one is the result of one loop, and we'll put sample size and the power with its corresponding power. So here you can use a sample 35, for example, to get the power if lambda is 5 and phi is 0.25. For the second simulation, you can use a sample of 30 if phi is 0.25 and lambda is 10. Sorry. For third simulation, even 50 does not give you sufficient power. And for the fourth simulation, you can use sample size of 50. You can also examine every single simulation result using the following subsetting method, like this, and so on. You can also plot the power curve, which will give you the plot against sample size and power, and will give you the corresponding arguments used in calculation of sample size. You can also adjust text and use multiple simulations on the same curve. Now, to present your data, you can plot multiple simulation results on the same curve, applying H and V and text functions to create a crosshair with description of text at the sample size that gives you sufficient power. So here's the sample size for the blue line, which is lambda is 10 and phi 0.25. The sample size here in each group is 27. So now assume that you have a ratio of case to control different than 1 to 1, for example 1 to 2. In this case, this function here, estimate power curve, will not give you the desired result, and you will have to use the function sample size. And remember that in case of 1 to 1 design, you can make use of this function or this function. Basically, this will ask you for more arguments, and this function will give you an object ready to be plotted and compare, as we see here, different simulations. So let's move to the other function, sample size. And as we discussed before, it will ask you for the following arguments, and here we put dummy data. Again, you get the source of this data from a pilot study, from literature, or from an expert opinion or a subject of matter expert. So let's try the first example 1 to 1, and we'll use the following arguments. And you can see that the sample size is 27 in each group, and so the total sample size will be 54. In case of one case to control design, you will use the k equals 2, and the resulting sample size is 21 for cases, and so the controls will be multiplied by 2. So the sample size of the control will be 42, and the total will be 63. So again, to present your results, you can say that sample size in case of 1 to 1 is 54, and in case of 1 to 2 is 63. Hope this helps, and thank you very much.